Hi everyone, welcome back. In this video, we're going to continue to get some practice with arrays, but we're also going to introduce a new concept around objects. Objects in JavaScript are going to be a way for us to basically bundle some variables together into one thing, and then that's going to become an object. We've also kind of hinted at the fact that arrays are also their own kinds of objects. So we're going to start to explain some of that syntax a little bit. And in a few weeks, we'll go a lot more in depth into objects, but we're only going to start scratching the surface in this video. So for this example, we're going to, before we even talk about objects and arrays, we're going to give ourselves something to work with. And we're going to revisit this concept we explored a few weeks ago where we had basically this like bouncing circle, right? Bouncing circle left to right in the window. We're going to expand that to adding the y-axis. So we're going to write a simple program where we have basically just a shape bouncing bouncing all around the window in some in a random direction. So let's start with that. I have some boilerplate already here. Like I said, I'm not going to go over that in every video from now on. So let's declare a few variables. Let's start with the x axis. Okay, so we're going to create a variable called x. And remember our motion idea, we needed a variable for the speed of the object. Okay, so this I'm going to go over this quickly because I've covered this in a previous video. So if you need a refresher on that, you can always go back and look at the week where we covered variables. So speed x, we're going to make that equal to a random number. So could start wanting to go left or right. And in draw, just to mix it up here a little bit, we're going to draw a rectangle instead of a circle. We're going to use X. Right? And this is a bit of a recap. Let's make it, I don't know, 200. Okay. We're going to make the rectangle mode center so that the coordinate of the rectangle is its center as opposed to its corner. And let's hit play here. Okay, so this is my rectangle. And we said in week 2, we said our basic equation for motion goes something like this. Motion is position plus speed. Okay, so in every frame, we want to take whatever the value inside speed is added to the position. So this gets the square moving to the right if we got a positive speed. And then we keep an eye on the position of our object. And if it ever crosses the left or the right edge, in other words, if its x value ever becomes less than 0 or greater than width, then we know it's time to turn around. And to turn around, we simply take the speed and reverse it by changing its sign, by putting a minus sign in front of it. And that gives us our basic kind of bouncing behavior we programmed in week 2. And to this, we're going to also add the y value. Okay, so now I have a circle bouncing left and right. And we're going to add the y value as well to this. So let's create a couple more variables. We're going to create a variable called y for the y value. And we're going to create a speed y as well. Okay, so these have to be different because we might be going left and going up or going right and going up. So they can't be the same values. And in fact, just to spice it up here a little bit too, we're going to, in setup, we're going to make this random. So we're going to start somewhere random on the screen, and speed x and speed y will also both get random values. Remember, if you put two numbers inside random, right, you get a range. So you get numbers between -2 and 2. So -2 means I go to the left, 2 means I go to the right, this means I go up, this means I go down, and anywhere in between. So we'll get a range of motion here. So we have 4 variables, all random, and here we're going to draw not using height divided by 2, but using y. And then we'll do the same thing here for the bouncing behavior, right? We'll say our motion is, we're going to add speed y to y. And we are also going to keep an eye on y. So if we get off the window, if we leave the window either at the top or the bottom, we know it's time to reverse the speed along the y-axis. So this is our basic kind of movement program. And we covered all the logic behind that in week 2. And let's do a couple more tweaks as well. I'm going to turn off the fill, set a white stroke just for fun, just mixing it up here a little bit. And I'm going to make this a, oh, interesting. Oh yeah, of course. So I should be saying, so my circle went too far down the bottom here. That's because I made a mistake. This part here, it should be y greater than height, of course. All right, because my window may not be a perfect square. And let's hit play again. So sometimes it goes faster, sometimes it goes slower, and again that's because the speeds are random at the beginning. And the reason we're doing it like this is that because we're talking about arrays this week, we're going to now talk about adding more of these moving shapes, of course, and sort of different strategies we can use to do this. And one final tweak serves no purpose, but just for aesthetic reasons, I'm going to round the corners of this box. To round the corners, you can add a fifth parameter to the rectangle function. That is the amount of corner rounding you're adding. So if I put like 15 in here, I'm going to get a just slightly rounded corner. Why not? So not important. Okay. So the next steps, what I would like to do is I would like to take this idea of a moving box and just kind of replicate it, right? So I can get, I don't know, maybe I get like 100 of these moving boxes, 50, whatever, the number doesn't matter. I'm going to create an animation where I have lots of these moving shapes. Okay? And in order to do this, we've talked about in the previous video, we're going to need arrays. There's no way around it because for each shape that I'm animating, I need 4 values. I need these 4 variables. So if I'm going to have 2 shapes, I need an x, a y, a speed x, and a speed y per shape. Okay? Each of them need to get their own values. They cannot be shared. If I'm going to have 100 shapes, I need 100 of these, right? One of each, so 400 variables in total. So we need syntax mechanisms that we can leverage the fact that the computer is very good at doing repetition, right? Counting things. It can do all the work for us if we use the correct syntax. So based on what we learned in the previous video, one approach to this that we could do is we could turn all 4 of these variables, right, into arrays. And then in setup, we would write a for loop that would initialize, instead of 4 variables, we would initialize maybe like 100 sets of 4 variables in the same way. And then in draw, we would change this code a little bit to kind of look up using the square brackets, right? Look up inside these 4 arrays at different indices inside a for loop to repeat and draw the same, have the same code, draw different squares in different places at different times. So that's an approach we could do. The thing with that though is it gets a little clunky. If you add more details to your square, right, you're going to need to create yet another array every time, and that can get a little bit unwieldy for more complex things you want to represent beyond a simple shape. So before we talk about refreshing arrays, we are going to also talk about the object syntax. So the object syntax in JavaScript allows us to take, let's say, these 4 variables, right, x, y, speed y, and kind of like place them into a bundle together, where conceptually we're going to say, let's say we have this thing called a box. Okay, it's technically a square, but there's already a square function in the language, so I'm not going to use the word square. I'm going to call this a box. Okay, we have this thing called a box in our program, and a box has a x, y coordinate, and it has a speed x and speed y, and maybe any other number of attributes we might dream up, like a color, like a size, whatever. Okay, a rotation eventually. Okay, so with the object notation, we can take these 4 kind of unrelated variables and we can explicitly bundle them together into a package. So let me show you how we can do this. So we're going to declare a variable. We're just going to call this variable a box. Okay. Now we saw here a box is going to have these 4 variables inside of it. So I'm going to just comment out here. I'm not going to comment out. I'm just going to reuse these in a second. So I'm going to first declare a variable. I'm going to call it box. And this box is going to be an object. The syntax in JavaScript to create objects uses the curly brackets. Just like with code sections, it leverages the curly brackets. So we're going to say box equal, and we're going to open and close some curly brackets. And then inside of there, we are going to then define the 4 individual attributes, individual variables that are contained inside my box object. So in this case, it's going to be xy, speed x, and speed y. So I'm going to grab this and I'm going to paste it into the curly brackets. Now we just have to change the syntax a little bit. So when we assign values to variables, this is how we do it with the single variable syntax. When we create an object in JavaScript, we have to change the syntax. So the value on the left is going to remain. This is going to become the name of the attribute, except instead of an equal sign, we're going to use a colon. Okay? So that's the first little bit of syntax we want to change. And often I like to not leave a space there. So I'm going to just put that like this. And then the other important bit of syntax we need to change is that instead of using semicolons, we're going to use commas, because we're essentially just enumerating what all the different attributes are of our box. And then the last one is not needed because it's the last one in the list. Okay. So technically those could be written as a single file, right? You could write them all like this. But for clarity, we like to kind of structure it like this with some indentation. So it's a bit easier to read the 4 attributes of our box variable. So what we did now is we created an object using the curly bracket syntax. And we said this object is going to have 4 variables kind of bundled inside of it. X, Y, speed X, speed Y. So if I do this and then run the code, because I commented out these variables, obviously this bit here doesn't work anymore. It's going to be like, sorry, I don't know what you're talking about. I don't know what X is, speed X. I have no clue, right? Because we've moved these inside an object called the box. So now if we want to access these values, these variables, we need to do this in the context of the box. So we're going to use the dot syntax to do that. So now if I want to draw the rectangle, I'm going to say box.x and box.y. So x and y are now contained inside this box object. Right? So now I have box, you see it's contained inside. X and y are contained inside, and so is speed x and speed y. So all of these are kind of now packaged together as one concept, one thing, one object. Get rid of extra spacing here. So we're going to go ahead and do the same thing here with all of our other variables. Okay. So now instead of just x or just y, we can just say box.speedx, box.speedy, and do this for all of them. So already you can kind of start to imagine one of the benefits of starting to structure our code that way is that maybe in the future we're going to write programs where we have different kinds of moving objects, right? Where we might have a box and then we might have a circle, right? Or we might have, I don't know, a box and a triangle or whatever, different kinds of moving objects. And they all share the same conceptual ideas, right? They all each have an X, a Y, speed X, speed Y. So now we can reuse those common names inside these objects, right? If I created another object, I could reuse these names because now their scope, right, is within these curly brackets. So in other words, I could have a box.y, and in the future we could have circle.y, right? So we can now reuse these common names and conceptually structure our program such that related variables are now bundled together. And in a short program like this, doesn't make a big difference, but you can imagine as we ramp up complexity, as we work even towards the game example at the end of the class, we're going to have all these different elements in the game, and the object syntax is really going to help us keep things organized so we don't get lost. Okay. So now if I hit play, my code's going to run again. Okay, so now I'm accessing my boxes, the variables that are contained inside my box, okay? My box object. It has an x, a y, a speed x, a speed y. I just packaged them inside a thing called box that I just made up. Okay, so this could be any name. I just picked a name that reflected what I was trying to represent. That's always a good idea to do that. So this is the kind of the basic object syntax in JavaScript, and it can go a lot more in depth than this. In a few weeks, we're going to talk about how to more formally declare our objects using classes, and we're even going to add, in addition to variables, we're going to bundle functions inside our objects so that our objects can do things with their variables. So it's going to go a little bit more in depth eventually. But for today, we're just talking about objects as a collection of variables, right? We just say, here's a bundle, and package these variables inside another variable that we can create. So what does that allow us to do when it comes to arrays? Well, the other benefit of now thinking of our box as this collection of 4 variables is that if we wanted to create, let's say, 100 boxes, we no longer need to create 4 different arrays. Okay, we could just make one array that contains 100 box objects. Okay? And each of those box objects is going to contain 4 variables. So we can achieve the same thing, but we're just organizing our code a little bit differently. And that's going to help us keep a handle on complexity as we create more interesting programs. So let's convert this to work with arrays so that we can take this logic over here that's creating random variables representing one box, and this logic over here that's drawing and moving the box. We can apply it to a large number of elements using arrays. So imagine here, instead of a box, we're going to create a variable called boxes, and this is going to become an array. Okay, this is something I like to do. If my variables, if my arrays have names that can be written as a plural name, I like to do that. We didn't do this with X and Y in the previous example, but something like boxes, right? I could write it like this as well. I could just turn box into an array, but here I'm just using the English language to give myself a clue that this variable represents an array of variables instead of a single one. I think it's going to help us make our code more clear. This automatically we're going to be reminded that, oh yeah, boxes is actually a whole bunch of variables, not just one, okay, by just making it plural. You don't have to do this. The JavaScript's not going to care if you call your variables whatever you want, but this is just good practice. So now we have an array called boxes, and we're going to do much like what we did in the previous example. We're going to write a for loop. We're going to say use a counter called I. We're not very imaginative with our counters. We're almost always going to use the variable I, because almost always when we create for loops, now that we know about arrays, we're going to be using them in a combination with arrays, and I refers to the index. And then we are going to say, I don't know, just to mix it up, we're going to start with 50. Okay? Right? We're going to repeat 50 times and counting from 0, and then we are going to increase I by 1 each time, giving us a perfect sequence to use as an index inside this boxes array that we created. Okay. Now, instead of initializing an individual box, we are going to say boxes bracket I. Okay. So we can do this as well. So now what we're saying is in the array boxes at index location I, put this object. Okay. So an object is considered a single variable, even though it contains smaller variables inside of it, kind of like think of these Russian dolls, right? We can put one object at one location in the array. So this is very convenient. And then inside there, we have the dot syntax to access the internal attributes or variable of the object. So this creates an array called boxes and then initializes the array with 50, right? 50 different box objects. Oh, I guess we no longer have the name box here. 50 different objects that each contain an X, a Y, a speed X, a speed Y. So this is as an alternative to creating 4 arrays, right? 4 separate arrays, which we could do as well, but I'm just in this one showing you another way to approach the same thing. So here, because we know about objects, we're going to create one array of objects. Just makes the syntax a little bit clearer down the road. So now that we've done this, we could also go and use a similar for loop. Right? So we're going to say, let's write a for loop that's going to count for us. It's going to go through, it's going to count up to boxes.length from 0 in steps of 1. And then in here, it's going to just tidy the code here, tidy code. It's going to run this code. Now we've got rid of our box variable, right? We don't have this anymore. We just have an array called boxes. So we're going to have to do some changes here. So we have some options. Okay. We could say, I'm just going to, for now, I'm going to copy this bit because I'm going to reuse it in a second. Okay. I'm going to copy it, put it down here, and just comment it out. So I want to grab this again in a bit, but for now I'm going to put it out of the code. So what we would have to do next is say, okay, this is our array called boxes. Right? So in here, when we want to draw the x variable, we would say boxes bracket I dot x, right? Because inside boxes bracket I, we put an object. We put an object defined here that inside of it has an x, a y, a speed x, and a speed y attribute. And we would do the same thing for all of these variables. Okay, so I'm going to copy and paste here to save myself some typing. So this is now the new version of our code using arrays. So we're logically doing the same thing. The only difference is now we're doing it inside a loop. So this code gets repeated, and every time it repeats, the only thing that changes is the index. So which object are we going to be working with? Which variables are we going to use to move and draw the box? So now that I've changed all of them, let's hit play. All right. So now we have, right, create, repeat 50 times. Each time, create a new object, put it into this array. And then in draw, repeat however many times we need to visit every object we created. So that's boxes.length. And then using the variables we find inside this array, draw a box, move its coordinates, and then make it bounce if needed. Okay? So same logic applies, except now we're repeating, right, and letting the for loop and the arrays do most of the work for us. And this is scalable, of course. We could create 150 of these boxes, right, or we could create 10. And it doesn't matter. We've set up our program to take advantage of for loops and arrays in order to achieve that. All right. So this works, but it's still a little bit, I don't love this syntax too much because well, there are times when you will have to do this, but this is a little bit not super elegant to do this. Like I don't like having these bracket I's all over the place. I find it's error prone and it gets a little bit confusing. So one thing we could do to make our lives a little bit easier is we could say, instead of having to do that, which works, okay, but we're just going to clean up the code a little bit, make it look a little bit more like that, what we had before, okay? This was a lot easier to read to me. So as we repeat, right, before we embark in this little bit of code, we are going to create a variable called box, and we'll say box equals boxes bracket I. Okay? So what I'm doing here is I'm creating a local variable called box. So remember, local means temporary. It's throwaway. It's only going to exist for the duration of this section. And I'm essentially creating a synonym for boxes bracket I. I'm saying take the object I stashed in the array at this location and then temporarily put this into this variable that's shorter, just called box. Okay. And now what I can do is I can get rid of that and I can bring back this code. I'm going to uncomment and let the sketch tidy it up for me. So now I can bring back this code, which was a little bit easier to follow. Okay, so first, right, take the box object out of the array, right, at bracket I, put it into a more manageable variable that's just called box. And now from now on, I could just say box.x, box.y, right? Knowing that every time the loop repeats, I'm going to grab a different box from the array, right? I'm going to start with the one at index 0, and then next time I'm going to pull the one from index 1 and then index 2 and so forth. And this is how this all still works. So no change here on the right to the actual output of the program, but a big improvement, in my opinion, in the readability of the code. Okay? So this is something that you can do that's pretty useful. And in fact, this is kind of a common thing to do, right? If you think about what we're doing here is we are writing a loop that its job, its purpose in our code is to iterate over an array, right? So by over an array, I mean visit every location in the array one at a time, and then inside the loop, do something with the variable that we find at that location. This is such a common thing to do when we're programming that there is some shorthand syntax we can use to make our lives even easier than that. So if we don't care about the index, right, which we don't here, sometimes you do care about the index. Maybe you want to use the index value inside the loop to do something, right? Some kind of calculation. You want to use the fact that each box has a different index for whatever reason. Then you can write your for loop like this, where it's important for you to know the index of each box. Okay. But in this case, we're not actually looking at the index at all beyond knowing which variable to pull from the array every time we repeat. So when that's the case, we have a little bit of shortcut that we can, a shortcut syntax that we can use to make the for loop even simpler. We can write it like this. We can say for box of boxes, and then open a curly bracket. So this is the ultimate convenience, right? This is going to do is going to create a variable called box here, and then the same as we're doing up here, a temporary variable to use inside the body of the loop. And this for loop is simply going to iterate over all the objects contained inside this boxes array. And we can do this when for any type of array. Okay? So if I hit play here, this is still going to work. Okay. Oh, and I just noticed I am getting a warning. Of course, because there is a function called box in the P5 language. I kind of forgot about it. The box function is only used in 3D to draw these 3D squares. Okay, so this is an important little warning here. It doesn't affect our program. It just means down the road, if I were to switch to 3D and try to use the box function, I'm going to run into issues because I just changed what the box function means. Okay, so not a good idea to do that. If I wanted to fix that, I could just call it B, right? So I could just call it B. I forgot about the box function. Usually always try to stay away from anything that's in the reference with your variable names. But in this program, because we're not using the box function, we're not doing a 3D program, doesn't really matter. If I wanted to fix it, I could just change the name, and now the warning goes away. Okay? So this shorthand syntax, right, allows me to basically do what we would do above here. Count using an index, and then using that index, pull individual variables out of the array. This is just a shortcut for this up here. So this is a common scenario. The only downside to that shortcut is that now we've lost the knowledge of which index we're at as the for loop repeats. Okay? Here, it doesn't matter. Sometimes there are cases where it is useful to know the index. We'll talk about those down the road. As we run into use cases that make this meaningful, we'll talk about it as we go. But a lot of the times, it doesn't matter. All you want to do is just go through an array and then do something with your objects or your variables that are stored inside of it. In this case, I'm using the variables to draw a bunch of rectangles, move them, and then bounce the speeds if need be. Okay? So in that particular case, I don't care what the value of I is. So this shortcut syntax just makes it even that much easier than this one to iterate over this array. All right. So take a step back here. We're going to do just a quick recap before we wrap up. So what did we do in this program? Well, first here we declared an array called boxes. And then unlike in the previous example, we created this array and then we stored not individual variables inside of it, but we created objects. At this point in the course, we can think of objects as bundles of variables. Okay? So the way we declare these bundles is we use the curly brackets, same as the code sections, right? Same as these ones, the same curly brackets. So again, you got to be really careful with your curly brackets when you're programming, making sure that they always match. And thankfully, the editor helps you with this by always highlighting the matching one. This is the number one error when you're learning how to program and your code doesn't work. 50% of the time is you have some mismatched set of curly brackets, right? Maybe I forgot one here. Everything goes to hell, excuse me. If you do this, it just throws off the entire syntax of the program. So always be very careful when you're creating your curly brackets. That's why I like to always, when I create the open one, I make sure the matching one, closing one is there. So be very careful with this in the beginning. It's very easy to make a mistake. So curly brackets, and then inside the curly brackets, we use the object notation, which says we create a variable. In this case, I'm going to call it an attribute of the object. So we give it a name, and then instead of the equal sign, we use colon, and then we put a value in it. So this could be a fixed value, right? It could be, if I wanted all of them to start in the middle of the screen, I could put in height over 2, right? Just to show you. This could be a fixed value. That would work. Here, I'm just choosing to make all of them random, okay? Or it could even be a number, okay? It doesn't matter. 100. I'm just choosing to make them all random, just for interest, okay? So we use the colon here, and then we say, what do we want this attribute to start out as? And then we use a comma to separate them out. Typically, we don't need a comma for the last one, but if you put it in, it's not going to hurt anything. So we separate them with commas. And that creates a set of 4 variables that are contained inside one package called an object. And then in our program here, we are using a for loop to iterate over the array. And we saw we have 2 different methods of doing that. One is kind of using an index as the counter, right? And then to make our syntax a little bit cleaner, we can sort of pull out the object from the array, put it into a temporary variable, so we don't have to have brackets all over the place, which are kind of annoying. Or if we don't care about the index, we learn about this super handy shortcut syntax, which allows us to just iterate over an array of variables and then using a temporary variable each time to access the value of the variables contained in the array. Okay? So even though we're using the same name here, this is a placeholder, right? This variable here changes every time the loop repeats. It takes turn, and then it takes us through all the values we've stored inside our array. Okay. So we're going to leave it at that for this week's example. Have fun with the code exercise. There's quite a lot of new content this week. I would say it's probably the heaviest we've done so far. So if you have to watch it twice, maybe not the worst thing you could do. We'll get more practice with arrays and objects and so forth as we continue to build on these fundamental kind of building blocks of programming. All right. That's it for this week. I'll see you next time.